Okay, this is the CNC dude here again, and I'm just working with our new 7M Titans of CNC 7M Operation 2 fixture, and this was gladly donated by our instructor Stephen Hadwin from 3D Machining in Oklahoma, one of our H-Tech instructors. And I've actually added the Mighty Byte XY pins. This is the Mighty Byte company right here. Mighty Byte company is actually right up this road from where I used to live in Manchester, New Hampshire. They're in Wolfboro, New Hampshire, I think it is, near Lake Winnipesaukee. But they make a lot of great work holding devices, and I remember the first product they made was a hex that had a bolt in it that would be like an eccentric. Anyway, let's look at their products. So right here, these modular XYZ expansion pins. These right here. So Mr. Hadwin had already designed this, and these are the pins right here. And I actually had to figure it out because we were going to make this and we have to order the pins. And which ones are we using here? So this says press fit pins and threaded pins. So this is like a typical install. Pins are intended for press fit or close tolerance removal slide fit applications. So we actually made it so it was a slip fit, which is this F dimension right here. So I actually went in and looked at the file. I'm going to just go shut these off. Because what I did is imported them. And we did the different text than what it came to originally. So when I'm looking at the file here, I was able to look up on history, edit feature, what those were. Right there, edit feature, and it says 832 UNC. So that's the size of that thread. And also if I'm doing an inspection, like measure this diameter right there, or if I could find it in the library. This is a 376 diameter, or I think you could click on the feature and identify where it is in the history. Anyway, back to this area. So I'm looking at my first clue is something with 832, and there's right here. 832 is the screw. There's only one of them. And we have stainless steel or mild steel. This is 17.4 pH and mild steel 12L14. And it says right here, press fit 3/8, and fit of F is 375 plus nothing minus 1. So that's their range. This is what they're going to provide you with. And some of the other dimensions. So when you go to design the fixture, and I think they actually give you some clues of what to put in there. Using some of these techniques here. But if you see right here, it says CAD file. So what we did is we went in and found the file. You have to actually register. But we were able to download the file. Some of this Mighty Byte stuff is available online, right in Fusion, but this one wasn't. So in CAM samples, there's some other stuff. But anyway, I have a work holding section, work holding, and I have a Mighty Byte department. So these I imported, and these other ones are another fixture we're going to work on. So these are the ones I imported, the 31740. So what I did is I brought them in and aligned them to this to make it an assembly. And there's also a screw that goes in here, but I didn't really need this for this demonstration. So this is going to be our fixture. And it's also a locator. That's why it's precision fit. So in this case, it's going to locate off of the counter bores from the first operation. So we go to the first operation of Titan 7M mill building block workbook. And right here is the blueprints. Right there it says the counter bore is 380 by 315 deep. So these are expandable. So we're looking up in the book here. It says the F. This is solid on this end. This is expandable on this end. So that's 375. And I think, I forget where it is on here, but what it can adjust to. I know I read in here somewhere. Anyway, so we machined the block and we bought these pins and assembled them. So we want to make a perfectly parallel surface here, and these are going to be locators. So you're going to place the part on top of this. So let's demonstrate that. Right? We go into my recent files here. All right. Right here, new fixture. So this is the fixture by itself. And this is my bolt operations here. This is the design side. So this is, right now it's upside down and tilted this way. And actually I did something called a stock model. I'm going to shut that off. So here's our part, and it's being clamped on the inside with those expandable clamps. Only we have this material on top. This is actually why it looks pink, is actually it's called a mesh file. It's an STL file. So that's what's remaining that we need to machine. Everything on this side needs to be machined, and it needs to be aligned. All of these have to be aligned to the other side. So how do we line it up? Where's our X0, Y0? So we decided we're going to use this diameter here as our X0, Y0, which means the first operation we got to drill deeper. We got to drill all the way through in order to get a wrench in there to expand those. When this piece is on top, right here. So notice there's through holes here. All right, let me go to the manufacturer side, right? All right, I'm going to go to operation 1, and this is our material here. I'm going to turn off this one, and this one, and this one. Okay, let me just fix the red, generate that, and generate that. Okay, I'm going to shut down operation 2 for now. So operation 1 is a big 1x2 piece by, I forget how long it is, 4.425 long. All right, so this is going to be a normal setup, and our XY will be edit, setup, and model orientation. We want X, Y, and we want model box point and this corner right here. And we already have it labeled 1001, and we're going to use we can use WCS1 for now, or 0 is the default. All right, so I'm going to regenerate all these. Anytime you make a change, you need to regenerate. Okay, now we're ready to simulate. I got tool path off, stock on, and tool is transparent. This cuts the top.